Today we will be discussing points of intersection between lines and curves. But before we proceed to this topic, I'd just like to discuss a previous video of mine about solving for two variables in two equations. So for example, we have 2x plus 3y is equal to 12 and x minus 3y is equal to negative 3. We can solve this by elimination from my previous video or by substitution also from a previous video. So let's try reviewing a substitution method for this one. So the substitution method, we can either isolate any one of these four variables. You can isolate either this one or this one, this one or this one, and then substitute it into the other equation. Let's say we want this looks like the easiest one to isolate because it's just x. So if we want to solve for x, so we have to remove this one. So x minus 3y is equal to negative 3. So to remove negative 3y plus 3y plus 3y, so this will cancel out. X is equal to 3y minus 3. It's this one. And then this value of x, which is taken from 2, we will substitute this value of x in to this x. So this becomes 2. Instead of putting x, we put 3y minus 3 plus 3y is equal to 12. So 2 times 3y is 6y, 2 times negative 3 is negative 6, plus 3y is equal to 12. So 6y plus 3y is 9y minus 6 is equal to 12. So to remove minus 6, so plus 6 plus 6, 9y is equal to 18. So dividing both sides by 9, y is equal to 2. Then you can use this value of y to substitute here or here to get the value of x. This one has a lower number, so I'll just use this one. So x minus 3, instead of putting y, I'll put 2 is equal to negative 3. So x minus 6 is equal to minus 3. So adding 6 on both sides, x is equal to 3. Now there's another method of solving for two equations in two unknowns, and that is to solve for y in equation 1 and solve for y in equation 2. And I'll show you first. So we have 2x plus 3y, so which is this one, is equal to 12. So let's solve for y. So it means to eliminate what is with y. So eliminate 2x and 3. I'll just use a shortcut. I will transpose. So 3y is equal to 12 minus 2x. And then to remove 3y, we have to divide 3 on all of them. So that will be y is equal to 4 minus 2 over 3x. And then so we'll do it in the other one. So x minus 3y is equal to negative 3. So to solve for y, so I'll just transpose, make it shortcut, like subtracting x on both sides. It will become negative 3y is equal to negative x minus 3. So we multiply negative on all numbers. It becomes 3y is equal to x plus 3. So we have to, so to remove 3, we divide 3 on all of them. Y is equal to x over 3 plus 1. So now, so I solve for y in the first equation, solve for y. Let's take an analogy. So if A is equal to B and A is equal to C, then we can say that B is equal to C. It's similar. So y is equal to this, and then y is equal to this. So this one will also equal to this one. So that's, I'll just rearrange this one. Y is equal to negative 2/3 x plus 4. Make it look like the slope-intercept form. So I will equate this one and this one. So that would be negative 2/3x plus 4. And then this one is equal to x over 3 plus 1. Now they have a denominator of 3. So we multiply 3 on everything. So this one, I'll just do it one by one. Negative 2/3x times 3 plus 4 times 3 is equal to x over 3 times 3 plus 1 times 3. This would cancel out. This becomes negative 2x. This becomes 12. This becomes x. This becomes 3. So I'll just transpose it to all the variables to the right and all the numbers to the left. So this becomes x plus 2x. So 12 minus 3. 3x is equal to 9. So divided by 3, x is equal to 3. And then we use x is equal to 3 to either 1 or 2. I think this is an easier one. So instead of x, we use 3. So 3 minus 3y is equal to negative 3. Negative 3y is equal to, 3y minus 3 minus 3 is transposing this one, minus 3. Negative 3y is equal to negative 6. Dividing by both by negative 3, y is equal to 2. So you will notice that this answer is also the same as this one. From what we have discussed earlier, we were able to find that x is equal to 3 and y is equal to 2 for both these equations. And now we can try to plot it in the graph. So I mean, for equation 1, let's do an x and y graph, x and y table. So if x is 0, so if x is 0 for the first equation, so this will become 0. So then it will be 3y is equal to 12. So dividing by 3, y is equal to 4. Now if y is 0 for the second equation, this will become 0. So it will be 2x is equal to 12, dividing both sides by 2. X is equal to 6. So let's plot that one. So if x is 0, so this is 0, y is equal to 4. So 1, 2, 3, 4. So this one. And then if y is 0, x is equal to 6, 1, 2, 3, 4, 5, 6. It is this one. So we can put a line. So this is your first equation line. Now let's do the second equation. X minus 3y is equal to negative 3. So x and y, if x is 0, then negative 3y is equal to negative 3. So dividing by negative 3 on both sides, y is equal to 1. Y is equal to 1, it's this one. X is 0, y is equal to 1. If y is 0, so x is equal to, if y is 0, x is equal to negative 3. If y is 0, x is equal to negative 3. Oh, it's, if y is 0, x is equal to negative 3, which is 1, 2, 3, 4, which is around here. Let's see. That will be your line. That will be your second line. So this is the first. So this is your first equation. This is your second equation. Now what's interesting is the point of intersection of those two lines will be what we found in here. So solving for the x and y of two equations, you will find your x and y. So this is your x and y. This is 3, 2. So 1, 2, 3. 1, 2, 3 for the x, and then 1, 2. So that is how you find the points of intersection between two lines. So solve for the variables of the two lines. Now this is also applicable to curves. And if you solve for the x and y of the curves, either a curve and a line or both curves, it will be the point of intersection. So before discussing the intersection between lines and curves, I just like to explain the equation of a perfectly perpendicular line or perfectly vertical line or perfectly horizontal line. So for example, if you have a graph and you have a perfectly horizontal line, and that line is 2 units from the y-axis. This is the x-axis. So if this is your line, this line is y is equal to 2 because it has a height of 2, y of 2. So remember x and y. This is left and right. This is up and down. So this is y is equal to 2. So if you do the x and y axis, x and y table, regardless of what number you put in x, so if x is 0, at x0, y is equal to 2. If x is 3, regardless of, then y is equal to 2. So this is the equation of your horizontal line. Now if you have a vertical line, so for example here, this is your x, this is your y, and this has a distance of 3. So your equation would be x is equal to 3 because this is the origin. It goes 3 units to the right. It has an x equal to 3. So if you do the x and y table, x is equal to 3. If y is 0, x will be 3. So from here, if y is 0, x is equal to 3. If y is 4, so go 1, 2, 3, 4, x would still be 3. So this is the equation of a vertical line 3 units to the right of the axis. So if you want to have the line on the axis, so for example, you have a axis, sorry about that. If you have the line, if you have an x and y, if you want your line to be on the x-axis, this line is y is equal to 0, because regardless of your x, y will always stay. It will not go above or below, so y is equal to 0. Now if you want to show that your line is on the y-axis, so if this is your line, that would be x is equal to 0, because it's on the y-axis. It's not going to the left or to the right. X is equal to 0. I'll just show that this is y is equal to 0. This is x is equal to 0. For example, you have an equation y is equal to 3x minus x squared. So quadratic, it's a second degree, so exponent is 2, so it means quadratic, so it's a curve, it's not a straight line. If you want to know the point of intersection with the y-axis, so this is your, with the x-axis, so this is your x, this is your y. If you want to have the intersection of that one with the y-axis, with this one, this is the y-axis, this is the x-axis, this is, as I said, is y is equal to 0, this line. So if you want to get the point of intersection, so you'll be solving this one. This is the first equation, this is your second equation, to get the point of intersection between this line and the curve, which is about this one. So you want to see the point of intersection of this one and that one. So if y is equal to 0, so you just substitute y is equal to 0 to this value here. So this will become 0 is equal to 3x minus x squared. So the best way is to use factoring. We can factor out x. So 3x minus x squared is equal to 0. So we can factor out x. So if we factor out x, what is left is 3 minus x is equal to 0. So if this is 0, so this we can equate this one to 0, and we can equate this one to 0 to get the value of x. So for example, so if this one is 0, if x is 0, then this is already your first answer. Now if this one is 0, 3 minus x is equal to 0, we can transpose x into the other side, so 3 is equal to x. So you get two values of x, so x is equal to 3 and x is equal to 0. These are your points of intersection. So if you plot this in here, x is equal to 3, so 1, 2, 3, this is your first point of intersection, and the second point of intersection is x is equal to 0. Let's try to plot this graph. So let's do an x and y table. So if x is 0, of course this will become 0, this will become 0, so y is equal to 0, so which is this one. If x is equal to, let's say, 1, if x is equal to 1, so y is equal to 3 times 1 minus 1 squared. So that will be 3 minus 1. So your y will be 2. If x is 1, your y will be 2, which is this one. If x is negative 1, so y is equal to 3 times negative 1 minus negative 1 squared. So it's negative 3. So this negative 1 times negative 1 will be positive 1. So negative 3 minus 1, which is negative 4. So in here, this is, if x is negative 1, y is negative 4. 1, 2, 3, 4. If x is 2, so let's say y is equal to 3 3 times 2, which is x, minus 2 squared. So that would be 3 times 2 is 6, minus 2 times 2 is 4. 6 minus 4 is equal to 2 also. So if x is equal to 2, y is equal to 2, that will be this one. So your curve will be like this. And see that the point of intersection with the x-axis is at 0 and 3, which is this one. If we use this equation, y is equal to 0, and this y is equal to this one, you can get the point of intersection. Here's another example. We want to know the point of intersection of this curve with the x-axis. So again, this is your x-axis, this is your y. If your line is along the x-axis, this is y is equal to 0. So you want it to be y is equal to 0. So y is equal to this one and y is equal to 0. So you can replace 0 into y. So 0 is equal to x cubed minus 4x. Or if we reverse, x cubed minus 4x is equal to 0. We can factor out x. X is equal to x squared minus 4 is equal to 0. This one is a difference of 2 squares, so we can still factor it out with x plus 2 and x minus 2 is equal to 0. So if we equate this one to 0, x is equal to 0, that is your first point. If we equate x plus 2 equal to 0, x is equal to negative 2. And if you equate this to 0, because it's 0, x minus 2 is equal to 0, x is equal to 2. So you have 3 points of intersection. So these 3 points will be along the points on the curve. So you have a curve which is like a snake. So it will intersect this line, which is y is equal to 0. At x is equal to 0, this is x equal to 0. X is equal to negative 2, so negative 1, negative 2. So this is the second point of intersection. X is equal to 2, so this is your third point of intersection. So it intersects the line at 3 points. So these are the other points of this curve. This is your curve. And plotting this 1 and negative 3, 1 and negative 3 is about this here. And then negative 1 and negative 3, sorry. 1 and negative 3 is at this point. And then negative 1 and 3, so negative 1 and positive 3 is this point. And then 2 0, so this one, negative 2 and 0. 3, at 3 it's 15, so this is 15. At 3, 1, 2, 3 is 15, so this is about this one. Negative 3 is negative 39, so negative 3 is negative 39, so it's around this one. So if you can trace the curve now, this like it goes like this. The curve is like this, so it's intersecting the line at this point, and this point, which you can deduce from the, you can compute from the these two equations. Here is another example. We have two curves. Y is equal to x squared minus 4x plus 5, and y is equal to negative x squared plus 6x plus 17. So if you remember our earlier discussion, if y is equal to a and y is equal to b, we can say that a is equal to b. So this is earlier we discussed about the solving for two equations in two unknowns by substitution. So this is for this purpose, because this equation is already at y is equal to something, y is equal to something. So if we want to know the point of intersection of these two curves, they are already equal to y, so we can equate this one to this one, and we can solve for the point of intersection. So if y is equal to this and y is equal to this, so we can equate them both. So that will look like this: x squared minus 4x plus 5 is equal to, the first equation is equal to the second equation, negative x squared plus 6x plus 17. Okay, now, so I'll just do a shortcut. I'll just use the transposition. So this one transposed to here, it becomes 2x squared. Now this positive 6x transposed to the other side becomes negative 6x, and negative 4x becomes negative 10x. And then 17x, positive 17x becomes negative 17x on the other side, plus 5 is negative 12. So the right side is now empty, it will be equal to 0. Now we can solve for x. There will be two values of x because it's x squared. We can factor out 2 to make the equation simple. We can divide everything by 2. By 2, by 2. So this becomes x squared minus 5x minus 6 is equal to 0. Now this we can factor out into two binomials. So what will be the binomial? So to give negative 6 as a product and negative 5 as a sum, so that would be 6 and 1. So negative 5, this would be negative, this would be positive, equal to 0. So if either of this is equal to 0, then this is 0. So we equate this one to 0, because if this becomes 0, 0 times this one is 0. So x plus 1 is equal to 0. Let's just transpose x. X is equal to negative 1. So this is your first point. If x minus 6 is 0, adding 6 on both sides, you get x is equal to 6. So this is your second point of intersection. Now to get y, so we can substitute it to either. We'll just use this one because it's positive. I'll just use this one in here. So if y, if x is equal to negative 1, substituting it to here, this becomes negative 1 squared minus 4 times negative 1 plus 5. That will be your y. 1 plus 4 plus 5. This negative 1 times negative 1 is positive 1. Negative 4 times negative 1 is positive 4. Plus 5, this is 10. So if your x is negative 1, your y is 10. If your x is 6, so substituting 6, so this becomes 6 squared minus 4 times, following that one, 6 plus 5. So this is 6 times 6 is 36. 4 times 6, negative 4 times 6 is negative 24, plus 5, that would be 17. Sorry, 36, 12 plus 5, 17. So your y is equal to 17. So even without drawing the curve, your point of intersection will be negative 1 and 10. So negative 1 and 10, this is your point of intersection. And then the other one is positive 6 and 17. 1, 2, 3, 4, 5, 6, and 17. It will be around here. So this is positive x squared will be going upwards. I won't bore you with the x and y table, and this is x. The other one, x negative x squared, will be a downward parabola. It will be like this. So they will be intersecting at this point, which will be an important part in integration. So if you want to get the points of the intersection.